Good evening, everyone, and welcome to our Constellation Crew program this evening. I'm Dana Thompson, the director of the Brown Planetarium at Ball State University, and I'm joined tonight with Greg, Nicolette, and Caleb on screen here. And Melanie's helping out in the chat. So if you have any questions or want to find some definitions of some of the objects that we're talking about this evening, check out the chat and Melanie's got you covered there. We're going to start this presentation, as we have been the past couple presentations, with kind of a mystery image / video for the crew to try to help or try to understand. And so crew, here we have the sheet, this blue sheet of spandex here that is connected to a hoop here with some, hooks and clips. And we have some weight or pressure in the middle of it that is pressing it down. And this sheet, what do you think this sheet is representing when we're talking about things in astronomy, these difficult science concepts? We have to use something to help us understand these things. So in astronomy, what might this spandex be representing here?
Thinking it represents the fabric of space-time.
Yeah, so the fabric of the cosmos, space-time, kind of what we can imagine is a part of our universe, how things work in our universe as a result of this space-time. So you might have heard of space-time. You might know that it's kind of like spandex here that can get warped by masses or energy in our universe. But what does it actually do when it gets warped, and what does this look like? Well, we have the space-time, this spandex here, kind of going down a little bit. But this guy actually has something more than just one mass making the space-time bend here in this demonstration. He has attached to this drill a wooden block, and on it are two wheels that are pressing into this, making two little divots here. And when he is going to push the drill, turn it on, it's going to spin. And we're going to see what happens to this sheet of spandex here as a result of these two kind of indentations here spinning around each other. What do you think, crew, is going to happen? What are we going to see in this spandex?
Definitely a disturbance in space-time.
Yeah, a disturbance in space-time.
Be very general.
I like it. Okay. All right, let's hit play here and see. And it's slowed down here so we can see it. So, for sure a disturbance, but ripples. And these ripples represent something that we have just recently been able to observe in our universe. And what are these ripples here representing, crew? They're waves caused by
gravitational waves.
These, yeah, they're gravitational waves. Thanks, Greg. You got this. All right, so they're gravitational waves, and you might have heard of that. We've been able to detect these gravitational waves from the constellation we're exploring this evening, Hydra. But before we go on to talk more about gravitational waves, how do we find the constellation that some of these events have been detected in? And Nicolette, you're going to help us find this constellation, Hydra. It's pretty impressive, right? It's the largest constellation in the sky, as a part of the 88 official IAU constellations, right?
Mm-hmm. It's really, really big. It even surprised me because I knew it was supposed to be quite large, but seeing it and actually going outside to observe it is just a really big constellation. And it can be hard to find because of that. You would think that smaller constellations are hard to find, but when they're all in the same vicinity and they're not all spread out, it makes it easier for me at least. But to help you guys kind of figure out where this giant constellation could be, we're going to be looking at our good friends Canis Major and Minor again. We talked about those a couple weeks back. So we're going to be looking at one of the brightest stars in the constellation and one of the brightest stars in the sky, Sirius. And if you guys can pick it out really quickly, it's the brightest star in the constellation. I can see it right now. Once you find Sirius in Canis Major, you're going to go straight up from Sirius and look for the star in Canis Minor called Procyon. Once you find Procyon, you'll be able to find one of the stars in Hydra called Alphard. There we go. Thank you, Dana. Alphard. Once you find Alphard, you have found a star in Hydra. Therefore, you have found Hydra.
Yep. Yeah, that's really like the brightest star in Hydra here, Alphard. And it makes a kind of with the two other stars that we pointed out here, a triangle in the sky. You can use the bright star Procyon and the little dog Canis Minor, the brightest star in the night sky Sirius and Canis Major, and connect it off to the east or to the left here from our perspective here in Muncie anyway, to find Alphard. And when you found that, you found part of Hydra, but remember Hydra is the largest constellation in the night sky. The ones that we explore here in the United States, for the most part anyway, a part of the 88 official IAU constellations, or the International Astronomical Union. And there it is. We're not even seeing all of it because there's this black kind of beam here. That is our planet. That's the horizon where the sky meets the ground. We're seeing a lot more of the sky than maybe you could see if you go outside and look south, which is what we're doing here in the simulation. We're seeing the southern sky after sunset here in Muncie. So here's south here, but we're kind of seeing more of the sky than what you would see because we're also showing all the way over to the east here. And then all the way over here on this side is to the west. So we're seeing a lot more of the sky here. It's such a large constellation, we have to.
I'm also surprised that the brightest star isn't near the head, or what I think would be the head of Hydra up there.
Yeah.
Sometimes it's the case.
The head does have like an actual like little circle of stars though, so it looks more like a head. And it only has one, even though Hydra had many in the stories around this creature. So we haven't explained what this creature is, and we're going to talk more about it at the end when we talk about our mythology. But it is, as you can imagine, kind of a snake thing because it's really long. It's got this little head at the top there. Okay, so Hydra is the constellation that a lot of interesting things are happening in, like the gravitational waves that we saw a little sneak peek of in the beginning. But we have to do a lot of discussion and a lot of explanation to get us all on the same page so that we can really appreciate what gravitational waves are and what it means to astronomers that we can detect them now. So let's move to see just one object in Hydra. And it's this. What is this, Greg?
Yeah, so this is Galaxy M87. It's also known as this, or M83. Sorry, yeah.
M87 is a really cool one with the black hole picture. This one's M83, like the band. Yeah.
So, sorry, yeah. So it's Galaxy M83, also known as the Southern Pinwheel, right? And as you can see, it is a spiral galaxy. It's really a barred spiral. And that's why we gave it the name, the Southern Pinwheel. And it's located about 15 million light years away. It's one of the brightest spiral galaxies we can see, and that's actually primarily due to the sheer amount of star formation that's still occurring in Galaxy M83. And we use it, so we can actually use this galaxy to study different supernova remnants. So we've actually studied nearly 300 different supernova remnants that we've observed that are part of Galaxy M83. And we've seen 6 actual supernovas observed just from Galaxy M83 alone, which is more than any other galaxy that we've seen, which is really interesting. And these supernovas, that we know have occurred and that we've actually seen occur, These are actually what leads to that amount of star formation that we see. And then that, pinkish red glow that we can see is caused by the massive amounts of UV light being absorbed by the hydrogen gas in this galaxy. And we know that hydrogen gas is the primary component of stars. Hydrogen is the primary component of stars. And so it just kind of gives us a clue as to how much of that star formation is actually occurring in this galaxy.
Yeah. So we have these distant objects out in space, and this one is in the constellation Hydra, and it's just a galaxy. And Melanie put a wonderful definition of what a galaxy is. And Greg, thanks so much for explaining what all these colors are, because yeah, there's a lot of colors here, and this is beautiful. What is it? M83 or the Southern Pinwheel?
Yep.
Southern Pinwheel. Why is it southern?
It's a great question.
I don't know. Interesting. Okay, we'll have to figure that out. Come back to it. All right, this is probably one of my favorite pictures that I've seen in a long time of space, for many different reasons, but Caleb's going to talk about this one to us, or for us. I think Caleb's yeah, Caleb, you're having a little bit of internet connection issues. So if we need to repeat anything, or if we need to kind of skip on to the next thing, we'll let you know. But go ahead and try it out, and we'll see if it works.
So this is actually known as 314, which is actually a 2. And despite a look,
okay, we're gonna have to, sorry Caleb, the internet is just so not working out for us today on your end. But I think Caleb was trying to say that this is NGC 3314. And in fact, this is actually 2 different galaxies, not just one. So this image shows 2 galaxies in a unique and interesting position, but despite the way they look, they are not colliding with one another. We do see galaxies collide with one another occasionally. Therefore, since they're not colliding, scientists have determined that these 2 galaxies are actually millions of light years apart, so really far away in space. When we look out into our universe, we're actually looking at quite a bit of distance. There's a lot of potential or possibility for objects to line up. But we don't see it that often. This is one really unique example of seeing 2 galaxies in our line of sight. And why don't we see more of this? Well, space is really big, really, really, really big. And there's just not a lot of actual physical stuff like galaxies or these stars making up these galaxies to have this happen quite often.
Do any of you guys happen to know if this is our actual picture, or is there a filter going on? Sometimes that happens. We see it in different filters. So
this looks like a visible image, so
Oh, sorry about that.
Yeah, you're good, Caleb. We can hear you a little bit. And it looks like there's just internet problems happening across maybe campus or Ball State's Wi-Fi here, because we froze up for a little bit, but it looks like we're good now. Caleb, you're still freezing up a little bit, but we'll push forward, no problem. But this has to be taken with some kind of filters, because in astronomy, when we do our observations or when we get beautiful pictures like this, we use telescopes with really sensitive cameras attached to them. They're called CCDs. And we have to put a filter over that to get different wavelengths of light, different colors, so that we can create a colorized image of what we're seeing, like the galaxies here. So we use a red filter, a visible one, or V, which kind of collects a lot of green light, and then a blue filter too. And that makes up RGB, what we're used to seeing when we use digital cameras now. It'll create an RGB image, or TVs will have pixels and RGB to help us see these different colors, because that's what our eyes can detect. We have different color receptors in our eyes, red ones, green ones, and blue ones. And with those, we can see all the colors of the rainbow and beyond. Well, maybe not beyond, but you know.
For sure.
At least the colors of the rainbow.
It's interesting that it's a very white. Like, there is blue, and you can see some dark colors to signify that there's a really thick dust clouds, particularly right in the middle. But there's a lot of white going on, which is surprising to me.
Yeah, when we were talking about this, Caleb found a lot of interesting information, excuse me, and pointed out that there are these dark regions here, and that's dust blocking the light. And really, think about it, if we didn't have this galaxy in the background, we wouldn't be able to see this dark area because it would be up against more dark area. Not really well anyway. Like, we might see it because there's the bright areas around it, but this really highlights it, which I love it. It's great.
It's similar to black holes, right? So we can only see a black hole if there's something around it. It's like we can only see these dust clouds if light. Not.
Yeah, we can infer using that information. Very cool. All right. Caleb, you still look a little jittery because of the internet, so
I cannot see you guys.
yeah, so we'll just keep on going here, no worries. All right, so friends, let's see, we got another galaxy. So again, we're going to explore these gravitational waves, what's interesting about them, how can we detect them, but first we have to figure out how or where to really even look, and we're going to look into another galaxy beyond our own Milky Way at this one here. Greg, what galaxy is this?
Yeah, so we'll see if I can get this one right. This one's NGC 4993. It's an elliptical galaxy that's about 140 million light years away. There's some really, really cool stuff that we can see coming out of this galaxy. There's some data to suggest that it has an active supermassive black hole in its nucleus. So that means that black hole is actually actively consuming material around it. And there's also data to suggest that this galaxy is the result of a collision with another one. But this image, which is really special, that's up on our screen right now, is actually the result of a collision of two neutron stars.
Yeah.
And
so
we call this. Yep.
Just so people know what we're talking about here. So this large image is of the galaxy that Greg was talking about, and then in this little box, we're magnifying it up here, and you just see this little smudge, but it's more than a smudge. Let's see it over time here, and let this run while Greg, you continue talking about what happened to create this smudge.
Yeah, so like I said, it was a result of a collision of a couple neutron stars, and we actually call this a kilonova. So I know we've talked a little bit about supernovas in the past, and that's when a star is massive enough that when it dies, it explodes. It explodes its outer layers out, and then can result in a neutron star or a black hole. Well, a couple neutron stars or a neutron star and a black hole can collide, and they create so much energy that we had to give it a new name. And that new name that we gave it is a kilonova. And a kilonova produces a high enough energy radiation that we can actually detect them, and we can see them, just like what we just saw in that image.
Yeah, I mean, you can't see individual stars really in other galaxies. The stars that are in this picture, those are within our own Milky Way galaxy, getting in the way, kind of photobombing the picture here. But when there's a really massive or energetic event like a kilonova, we can actually detect it here, and that's what they saw here. So yeah, it looks like a smudge, but it's really cool. There's a lot going on here, and we see this with telescopes gathering that information in the form of light. But now we're into the era of multi-messenger astronomy, which means that we don't just have light from objects that are very distant from our Milky Way galaxy or our Earth to explore. In astronomy, we have particles, which we've had for a little while. We've had like cosmic rays, they're called, or other particles that we can detect and explore. And that will give us information about objects in our universe that are really far away. But now we have gravitational waves, and gravitational waves have kind of opened up a new area for us to explore. And they're created by neutron stars that are eventually going to merge and create the kilonova that we just observed in that picture. All right, so this is an artist's depiction of two neutron stars. Neutron stars are really dense, massive objects. There's a lot of gravity happening here. And since these neutron stars are close to each other, they can orbit each other in a binary system. And so let's keep this playing. So you'll see it orbit each other. And eventually they'll get closer and closer and kind of speed up this orbit here. And this is showing kind of these ripples that we saw at the very beginning of the episode here. Those ripples are actually, they're not like gas or anything coming from these stars. It's just showing us what is maybe happening to space-time and the fabric of our cosmos as a result from these really massive things going around each other. So those ripples, those are gravitational waves in space and time that we can detect with ultra-sensitive detectors here on Earth, like LIGO. Okay, so they collided eventually and created something that looks like a supernova, but it's so much more powerful, so it's called a kilonova. Pretty impressive. What's left over? I don't know, Greg. What happens when they collide? It's a leftover bit.
Yeah. So the neutron stars that collide, I believe, just become more of a massive neutron star. I'm not entirely sure if they have enough mass to become a black hole, but I'm pretty sure when two neutron stars collide, they become just more of a massive neutron star.
Yeah.
Now, when like a neutron star and a black hole collide, we know what that still makes, right? That still makes a black hole. Or when two black holes collide, again, we know what that makes.
Yep. So a black hole and a black hole, big one probably takes in the little one, and they're not like, none of them are little, so can't really say that. But like the bigger one takes in the smaller one and make an even more powerful, more massive black hole. Black hole against.
No matter what. I was saying no matter what, the black hole always wins. So.
Yeah, exactly. Yeah. Okay, so black hole against a neutron star, the black hole's going to win. Neutron star versus neutron star collide, probably just make another neutron star. Like, at least what's shown in this depiction, because that is not a black hole.
No,
we know black holes are black, like, unless we have stuff going around them, illuminating the area around the black hole.
I have a question actually. Do we know what two neutron stars colliding together forming a black hole would look like? I mean, if they had enough mass, I
don't know like the limits of it all. Because Greg mentioned that it's probably not massive enough to actually form a black hole, but maybe there are really massive neutron stars that are almost at that limit, and so if you do have another one added to it, it might go over that and create that black hole. Yeah,
because I think the minimum mass for a neutron star is 1.4 solar masses, if I remember correctly, right?
I don't remember specifics of how, but there is a limit, because at some point when it gets too big, it's not able to be a neutron star anymore, because it's not able to heat up the neutrons that's in it, and it becomes more difficult to keep that structure together without getting too much into detail with sciencey stuff.
Yeah, I mean, like there's this pressure that is existing at these cores or in these stars that are leftover bits from larger, more massive objects dying. So stars that are more massive than our sun will eventually collapse and form a neutron star, or in really extreme cases, a black hole. But there's a certain pressure, Nicolette, I think you said heat, but really it's like electron degeneracy pressure, or there's the neutron degeneracy pressure, whatever, that will make it still be able to support itself and be an object and not a black hole, kind of like we see.
Right.
But it is a more complicated thing. And as far as the numbers go, I'm really bad at remembering numbers. I look at tables and everything when I needed to ever do like the math with it all when I was in school for physics. And you pick it up over time, you know, like I remember some of the numbers just because I talk about it so much. But I don't talk about the mass limits for some of these objects, for the creation of some of these objects to the public too much.
Yeah.
Melanie gave us an answer to one of the questions that we had earlier of why is it the southern pinwheel? So I guess there's another galaxy similar to the Pinwheel galaxy that we looked at just a few moments ago that is called the Pinwheel as well. So there's a southern pinwheel, and then there's the Pinwheel M101. And it's similar to it, but it's in the southern hemisphere, at least in the southern hemisphere sky. So they call it the southern one. Thanks, Mel.
Oh.
I thought it might have something to do with that, but sometimes there are certain things that you can only see in the southern hemisphere. They don't ever really...
Yeah, there's some things that you can only see in the southern hemisphere from our location, or from the location on Earth. Excuse me. But we can still see some of the southern hemisphere sky because we're not at the North Pole on Earth. We can still see some of it.
It creeps up. It just doesn't let us see the whole thing.
Yeah. All right, we're gonna keep this episode kind of short tonight. And before we move on to our mythology section of the episode, I just wanted to point out that tonight here in Muncie and really anywhere in the States and 41 degrees-ish north latitude, you can see this beautiful crescent moon by a red object in the sky in the southwest after sunset. And this red object is the planet Mars, where Perseverance, the rover, just landed recently. So check out tonight, if your sky is clear right after sunset, go out, try to find the moon and look for the red object by it. That's Mars. It's by another red object that's a little bit lower in the sky, and that's the star Aldebaran, a red star in the constellation of Taurus, the bull here. There's a lot of cool things you can find in your sky tonight, including the constellation that we are focusing on, Hydra. All right, so there's a lot of stories about Hydra, and to help us tell them, we have our good old ancient picture drawing of it. And Caleb, I think your internet's working out pretty good, which is great because you are going to tell us all about the mythology of Hydra.
Yes, I'm going to tell you all about Hydra. As Dana previously said, it was a monster that could have more than one head. There's actually kind of modern depiction of it in the Disney film Hercules, because in the mythology, Hercules was the hero who killed the Hydra as part of one of his famous 10 labors. The 10 labors of Hercules were tasks he had to perform as kind of a penance for something he did in the past. So one of those was killing the Hydra. Now the Hydra is a pretty dangerous monster because every time you cut off one of its heads, another or two more would go back in its place. So basically, Hercules had to get very creative on how to defeat the monster, and it could also spit poison too. So that made it dangerous.
I heard that Hercules had to get a friend to kind of cauterize the heads after he cut them off.
So he would cut it off, and then like his I think his nephew would then use a burning torch to basically cauterize the neck before it can grow back.
Yeah.
So.
But there's one head that was immortal, right? And that's why there's only one in the depiction here. Whereas the other heads were what? I don't know, I guess kind of
Mortal.
dispensable. Yeah, mortal. I guess that's the other word. Thanks.
Yeah, the immortal head was in the middle.
Okay.
Yeah. So.
Yeah. I don't usually
As
look
long-
up any of the mythology. It was just not my area. So I did actually read about it a little bit today. So I was very excited for it. Yeah, it's like, okay, well, isn't this supposed to be the creature that has multiple heads, but then it only has one in the sky? So that's why, is because it had the one immortal one. And that's why it ended up in the sky, immortalized for all of time. It's a lot that we could go into here. Like, there's a crow associated with the story and the cup there. So the crow is still a constellation, Corvus. And the cup is as well, Crater, I think it is. But they're smaller, more faint constellations that we don't usually talk about too much in the planetarium. Okay. All right. So, Nicolette, did you want to give us a little bit of a history on some of the other cultures that you were seeing, or learning about, for this constellation?
I would love to. I'm super excited. This was really fun to do research on, and I highly recommend looking more into it if you guys are interested by the end of my spiel tonight, because honestly, it is really fascinating. So we're going to start with Chinese astronomy, which is, again, I'm going to say it a million times, extremely fascinating. So in Chinese astronomy, their constellations are a lot different from ours. In fact, I've looked at some of their sky maps, and they're actually a lot smaller, and they have different names and, of course, different stories to go with them. But we're not going to get into too much detail about each of those. We're going to mainly talk about what's called the 4 symbols of Chinese constellations. So there's 4 of them. Each of them are some type of animal, but we're going to focus on 2 of them right now, because in Chinese astronomy, Hydra, it being so large, is a part of 2 of the quadrants, or 2 of the symbols. That's what the symbols are for. They're quadrants of the sky to make it easier for Chinese astronomers to take a look around and see what's going on. So the 2 symbols that are involved with Hydra are called the Azure Dragon, excuse my pronunciation if that's not correct, and the Vermilion bird. So the dragon represents the east part of the sky, also is representation of spring, and its element that is associated with it is wood. There's some other details that you can study about it. It has a color as well that's kind of associated with it, but that's kind of the gist for the dragon. It's really cool. It has a little bit of some stories of how it's supposed to represent chaos, but there's that I would leave to you guys to do some more research on, because trust me, there's a lot to go into. The other symbol, the Vermilion bird, is to represent the phoenix, or a simple bird. It is red, its element is fire, and I believe it's south. Yes, it is south. It represents the south. Now, of course, there's north and west, a tiger and a tortoise, but the Vermilion bird and the dragon are the only ones that intersect with Hydra. But again, very fascinating, and each section has multiple constellations within it. I really recommend looking up a sky map. It's actually very cool. But keep in mind that if you do some more research, and you'll notice that the east and west symbols are flipped, and some people get confused. That's because when you look at a sky map, you have to look up. We may have explained this in the first few episodes of Constellation Crew, but you have to take your paper, if it's a piece of paper, and look directly up in the sky and make sure that your paper is pointing north or south, whichever you prefer, and then they'll eventually line up. But it looks flipped when you look at it in the opposite direction.
Yeah.
So don't be alarmed. They're not misnamed. But that is the Chinese astronomy, or Hydra, which is really cool. We also have some Hindu astrology going on with Hydra as well. So for those who don't know, there is a form of Hindu astrology, and excuse my pronunciation again, Nakshatras. So it involves the moon. Our zodiac involves the sun in the zodiac constellation circle with all of our zodiac constellations. For this form of astrology, they use the moon instead. And because of that, there's 2 more signs for each zodiac sign that we have. That's why the dominant zodiac sign for this astrology sign in Hindu is Cancer, because that's when the moon is in Cancer during the time that you're born. And of course, with astrology, there's a lot to go with it. Some things are really fun, like it tells you what career path you can go into and really fun stuff like that. So if you're interested, I highly recommend doing your own research and see what sign you are. The sign we're looking at is Athleisia, is a part of Hydra, which is super fascinating. And it's mostly because it's a monstrous constellation or zodiac sign, and its monster, coincidentally, is a serpent or a snake, which is Hydra. Super cool.
Yeah. I mean, when you do have a really dark sky, I can see where they get a snake out of this. Some constellations, they don't look like what you are expected to see, but this one I get.
Yeah.
But only in a dark sky or the planetarium.
Mm-hmm.
I think about it. There's a lot of snake constellations. There's Hydra. I mean, the Draco's often depicted as a snake.
Yeah, if you count Draco, there's 3. There's Serpens, which is by Ophiuchus.
Serpens.
Serpens is the only constellation that is actually split, because Ophiuchus, the guy holding it, is in the middle of him. So it's pretty interesting that usually we have these. We have the constellations to map out the sky, but this one's actually split into 2 different areas, but it's still the same constellation, Serpens. All right, so let's go ahead and wrap it up there. Keeping it a little short today, but we have something interesting happening tomorrow. Not necessarily from the planetarium, just something that the Earth does every year or so, and it goes through a vernal equinox for us in the northern hemisphere tomorrow. What does that mean, crew? Does anyone want to explain what happens on this day?
It means spring.
Yeah, the first day of spring. Okay, so it's the first day of spring. It's when the sun gets equal, it's when the Earth, or when we experience equal day and night, based on where the Earth is in orbit around the sun. And it's when the sun sets directly in the west, for the most part, and rises in the east. Otherwise, you always hear the sun rises in the east and sets in the west, but no one ever tells you that it doesn't rise exactly in the east all the time and set exactly in the west all the time. We see it rise south of east or north of east sometimes, and set south of west or north of west sometimes. This is all a lot more understandable if we actually had a picture of us all, but we don't, unfortunately, so just go with it. So we
Trust
can
you.
Yeah, we have the sunset exactly in the west for the most part tomorrow, and rise in the east tomorrow on the equinox.
Dana, if I remember correctly, the spring equinox is part of what we use for mapping the sky for astronomers.
Yeah, the vernal equinox is like a point in the sky, technically, kind of where things line up just right in a certain time of the year, and the geometries of, the Earth going around the sun. And it is a point of interest for astronomers, and where we can measure things out, like right ascension, I think, and declination, which is equivalent to longitude and latitude here on Earth for the sky. So it's just another way of mapping the sky, basically.
Also, if you want to observe the sun tomorrow, you'll note it's tomorrow's the equinox, right? Tomorrow's the equinox, so you should be able to see it rise directly out of east.
Yes.
And set directly in the west. So.
Yes. Yeah. Don't look at the sun with your eyes, though. That's a bad thing.
Yeah. You get this fuzzy stuff in your vision after that. Not saying that directly at
Yeah,
the
you
sun.
don't. Yeah, it would be a bad day.
Don't do that. Yeah.
But yeah, you can still look in the general direction and experience that. But remember, it's only for the northern hemisphere. We have to remember that we are part of a whole world with lots of different people on it, and the southern hemisphere will experience not the vernal equinox or the spring equinox, but the autumnal equinox, and they're getting into winter where we're going into summer here.
I'm so sorry. I mean, it's probably still very warm down there, so their winter is like our spring, but still, this cold. I want spring, please.
I feel bad for the penguins in Antarctica. It's going to be the cold, dark season for them.
I
think they like it. They're used to it.
Yeah, that's why they don't come down here. They like it up there.
They live there. They know where they made their home. Yeah. All right, everyone. Thanks so much for tuning in this week for the Constellation crew. We explored Hydra and gravitational waves. If you need to rewind to watch any of the content that you maybe missed, please do. We're going to also put this on our YouTube page on Monday, and it'll be there for you to check it out too. Next week, crew, do you remember what we're exploring next week? The crab.
Isn't it Cancer?
It's Cancer, the crab. So if you are Cancer in the zodiac sign, you might want to tune in and explore the constellation Cancer and all the interesting things within that constellation. All right, everyone. See you next week. Have a wonderful weekend.
Bye.